Okay, so as a reminder, distance is around a circle. It's the perimeter of the circle. And the formula, or circumference, sorry, is 2 pi r. So if we go to our notes, right here we have arc length. If you can please do me a favor, and I would like everybody to do x, underline that x. You will be filling in a number for x in this formula. That x, do y'all see how it has a degree sign? That is the measure of the arc right here. What else is that the measure of that we learned this unit? Do y'all agree these are going to be the same number, whatever they are? So if you know the angle, central angle, you know the arc. If you know the arc, you know the central angle. That's what x is. And again, what do you think r is going to be? The radius. Those are the two things you will be filling in to find arc length. You do not have to have this formula memorized, but didn't I just tell you that the arc length is part of the whole circumference, right? So that's why it does x over 360. Do you agree a whole circle is 360? Are we looking at the whole circle when we're doing arc length now? Arc length is part of the circle, just the arc length of the circle. And then this right here is the circumference that we talked about, 2 pi r. So we're basically taking a portion of that circumference. So please open up your notes. And I'm just going to write the formula right up top so I don't have to write it every single time. So the formula of arc length is going to be, we usually label it S equals. It's going to be S equals x over 360 times 2 pi r. That is the formula we are going to be using anytime it asks us to find the length of an arc. So for this right here, it says find the length of EF, arc EF. So because it wants the length, first of all, what is my x? 120. That is, do y'all agree that's my degrees of this and this? And what is my radius? My radius is 6. So now I'm going to plug in those two things into this formula. So S equals, x is 120 over 360 times 2 pi, and then what's my r? 6. All right. When you are plugging this in the calculator, I need everybody to look up. You're not going to, you don't need it right now. I just want you to look up. You are going to do two things. The first thing you are going to do is you are going to type this in, 120 divided by 360. Please make sure you arrow over. You are not going to type in pi. You're going to leave pi out of it. So your answer, when you give me an answer, is going to be 4, and then your answer is going to have pi in it. So when you type it in the calculator, you don't put pi the first time. So 4 pi, what's my units here? Meters is my answer. Could you put pi? You can. If you put pi to do it in Desmos, you can just put pi and it turns into the pi symbol. Or if you have the keyboard up, there is a pi symbol down here, if y'all can see that. If you put pi, I'm actually going to prefer y'all don't. But you can also give me the decimal answer of 12.57 meters. These are the same thing. All right. Again, I'm going to prefer the top one because y'all see how pretty and clean that is? 4 pi. So I'm going to say don't put pi in your calculator. But if you don't put pi, you have to remember to put pi in your answer. Okay. And then this is the decimal. Again, if I were to put 4 pi in my calculator, it gives me the decimal. You do not need to do that. I just wanted to show you how to do that. Okay? This is what I prefer right here. This is correct, but this is what I prefer. All right, let's do number 2. Number 2 says the diameter is 24 centimeters. If the diameter is 24 centimeters, what does that tell me? What's half of it called?
The radius.
The radius equals 12 centimeters. So my R is 12. And what else do I know here? My X. My X is 60, and I'm trying to find the arc length of CD. So what am I going to do? S equals X over 360. You are just plugging into this equation. Times 2 pi, and what's my R? 12. And what am I going to do from here? Just type it into Desmos. So I'm going to say S equals 60 over 360 times 2. I'm not going to put pi, and I'm just going to put 12. And what is my answer? 4 again, but 4 is not my answer.
Would you be wrong to not include 4 pi?
Yeah, no, you'd be fine to not include S equals.
4 pi centimeters.
4 pi centimeters is my answer. Yes, what's your question? No, that's what Maya just asked. No, it's the same thing. Yeah. I know I don't usually put it. I don't know why I did this time. And that is how you find arc length. You're literally just plugging into this equation. Am I always going to give you this equation? Yeah. Yeah, you don't have to memorize this at all. You just have to know how to use it. Now, look at this next question. Calculate the sector area. Is that the same thing as the length? So we aren't using this equation for that. Okay? I actually want you to slide on over to this example 3 on the side. The last question I'm going to do with you about arc length actually has you working backwards. It says a circle has an arc length of 3 pi. So this time it's telling you my S is 3 pi. And it has a central angle of 45. What is that 45 degrees here? That's what my X equals. What does it want us to find? It says find the length of the radius. Well, I know S is 3 pi, and I know that's going to equal this equation right here. X over 360 times 2 pi r. Do y'all agree with that? But instead of X, what's my X? 45 over 360 times 2 pi, and I don't know what R is. Write this down with me, please. How do I figure out what happens here? You are going to use Desmos, and I want y'all to look real quick. Do you see how it has a pi on this side and a pi on that side? Those cancel. And I'm going to be left with 3 equals. I'm going to put this in my calculator. So, what do we got? What is 45 divided by 360 times 2?
You don't include,
we don't have R, so I don't include R. So what did I get? 0.25, and I'm going to bring down the R. I just put that in my calculator. Write that down if you need to, so when you're looking at stuff later, you're like, I don't know what I did. We put it in our calculator. And then what am I going to do now? How do I get R by itself? Divide by 0.25. And what you do to one side? What is 3 divided by 0.25? So my radius is 12. So to work backwards, you plug in to what you know, put it in the calculator. Plug in what you know, put it in the calculator, and then you'll simply divide. You have a question?
How is that 12? That doesn't 3 divided by
Yeah, because you're dividing by a decimal. So you're taking those three things and cutting them into 0.25, do y'all agree, is 4 parts?
Yeah.
So you're cutting those 3 pieces into 4 parts, which creates more.
Okay.
Yep.
So is this for 3 times 4?
Yeah, essentially, exactly. Yep.
For at least this one.
For decimals. All right, that is the arc length. I need everybody to close their notes, please. We're almost, well, not almost done. We're halfway done. The other thing we talked about was area. Remember, area is filling in how much space there is. So the area of the volume of this room is how much air is in the room. But the area in the room is how much floor, how much carpeting there is, right? So the formula for area is pi r squared. I want you to think of, well, kind of not really, but think of your circle as the radius is 1 base and the height as 1 base. Let me say that again. The radius as your base and the radius as your height. So radius times radius is, base times height is r squared. And then the pi is because it's a circle. Again, you're going to learn a lot more about why it's pi if you take pre-calc. But whenever we are finding the sector area, instead of finding the area of the whole circle, we are just finding the area, can y'all color that in, of a piece of the circle. I want to know how much space is right there? How much room is right there? Yes. So this is like asking you, how much pizza did you eat? Instead of you saying 1 slice, you could say, this many inches of pizza. That's what sector of an area is. Where would we use this in the real world outside of this class? Like, are you actually going to calculate the area of the pizza you eat?
No.
No, probably not. But where in the real world could you maybe use this, or could you see this being used? What? With buildings. Have y'all ever seen a building? Does Jersey Village have it? No, but some of the high schools do, where they have like a semicircle as like a courthouse has them sometimes, where like it's like a semicircle instead of a full circle in their building. Oh yeah, in elementary school, a lot of the teachers have like a semicircle desk, right? So that's just filling out how much material do they need for the carpet. That's how they would fill. That's what they would use this for. All right, things like that. And the same thing goes for this. We are going to fill in x and r again. What is my x? Right, but what does it represent? Sorry. It still represents the arc. It still represents how many degrees is the arc, or how many degrees is that angle. Same thing. Those are the same answers because it's a central angle. And again, what does r stand for?
Radius.
The radius. Now, how do you know which formula to use when? Because they look so similar.
Is the top one only trying to find the arc?
Only trying to find the length of an arc. What is the bottom one trying to find? The area. So you are only going to use this bottom one if your problem says the word area in it.
Okay.
And then it'll usually have an arc with it versus the area of the full circle. So for this right here, it says calculate the sector area below. Right here, I'm just going to write the formula. This is called A. A and a little s means area of the sector is x over 360 times pi r squared. Y'all saw that?
Mm-hmm.
Okay. Make sure we're not going into paranormal over here.
Wait, what? Like whenever you say that.
No, y'all saw the lights blink, right?
I want to say it so bad. My eyes were on my paper.
Okay, never mind.
I know.
You're just too tired. Okay. What information is what?
The 120 is your x.
My 120 is my x because that's the degrees, and my 16 is my...
Radius.
And I am just going to plug into this formula. 120 over 360 times pi 16 squared. Plug in what you know, and then what do we do? Just put it in Desmos. Again, you don't have to put the A of S. You can just start saying 120 over 360. And am I going to put the pi?
No.
Don't put the pi. 16. Can you put the pi? It won't be wrong if you do. Bless you. Okay, so if it's a decimal, what I would like you to do is make it a fraction. How do I make something a fraction in Desmos? Just click this button right here, and I do want you to just make it a fraction. 256 over 3. 100%. Yeah. No. Oh, no. I'll show you in a second. It's going to be 256 over 3. That's not my answer, though. Pi. Don't forget your pi. And this is meters. And because it's area, next to the meters, you're going to put a little squared sign. If you put pi in your calculator, which again isn't wrong, I just don't love it, then you're going to be rounding. So your answer would be 268.08. So it's not wrong. It's just not my preference. If you do that, it's fine. And to put pi in your calculator, you just type in pi. Alright, you don't need to solve it because not all of you have your calculators out, but I would like you to set up your equation for this next one. Can you please just set it up? It says right here, find the area of the sector. So we know we're using this formula. What did y'all get for x? 120 over 360 times pi. What did y'all get for r? 12 squared. Is that how you set it up?
Yeah.
That'll be half the points on your assessment, just setting it up. And then the other half is giving me an answer. So 120 over 360, I'm not going to put the pi. 12 squared is 48. So what's my answer? My answer is not 48. 48 pi. And my units here are inches. You always put the squared just on the units, not on your number. The squared is just your units. If you were to put pi, which again, I would also accept as your answer 150.80 if you put pi. All right, last but not least, it says this area of a circle is 225 inches. This is the area of the whole circle. Find the area of the sector, so that's what we're looking for, whose central angle has a measure of 45. So to find the area of the sector, what's my x? 45 over 360. It did not give me a radius this time. What did it give me? It gave me central angle. We already dealt with that. What else did it give me? It gave me the area of the circle. Do you agree? We already talked about this. Do you agree pi r squared is the area of a circle?
Yeah.
So instead of filling this in, I can just put this right here is pi r squared. So I can just put in 225 pi. It already did that work for me. And now what do I need to do? Yeah, put it in the calculator. That easy. So it gave you most of the information. What is it? 225, and I'm not going to put pi. So what is my answer? I want a fraction, not a decimal. It is 225 over 8. And then don't forget pi at the end. Inches squared. That one was weird. I don't know if I'll be giving you anything like that. I know I won't on your assessment. It was weird. All right. If you can please get your notebook, we are going to glue this into page 63. Arc, length, and area of a sector. Glue that in, please. Alexa, can you do me a favor and hand glue to each group of desks for me? All right. All right, you have, after you've glued this in, you have the rest of the class period, which is about 20 minutes, to do 1 through 10 on this worksheet. I want you to star number 3. Number 3 is like example 3 right here. Number 3 is like example 3. Be careful, it's working backwards. All right? The front is all length. If you look at all of them, they're length. I think the back, except number 5, the back is all area. All right? I need to see your equation and then your work. Don't forget to put pi as your answer. I will come around and help you if you need it. Bye, Pink.